Okay, if we shine light on some metal, in my case this is lithium, we can eject electrons from this metal. But not with every light we can do this. If I have not enough energy of light, the process will not ever occur. Red light cannot eject electrons from this lithium metal plate, and yellow light cannot as well, green light cannot as well. Only the light with appropriate wavelength, so I can say with appropriate frequency, we also call it threshold frequency. In general, I would say with the appropriate amount of energy will eject the electrons from this metal. Okay, 525 nanometers, so let's do like this, 525 nanometers. Okay, and now I can eject some electrons from this metal. So the amount of energy that I have now is called work function. This is the amount of energy that is enough only for ejecting these electrons from the metal, but they don't have any kinetic energy. If my light has more energy than just work function, then this amount that equals work function. So these electrons also will have kinetic energy after ejecting from this metal. Let's do this. Okay, now I have a photocurrent, we call it photocurrent in my circuit. And these electrons that are ejected from this metal, we call them photoelectrons. I want to show you first that this current in the circuit depends only on the intensity of this light. If I change the intensity, current will change as well. For example, less intensity, less current, because less intensity means less photons per second. Less photons per second means less electrons ejected from the metal per second. So we have less current in our circuit. If the intensity is greater, so of course we have more photons per second, and we have more photoelectrons per second as well. So we have greater current here in the circuit. Okay. If I will increase the frequency or decrease the wavelengths, so in other words, I will increase the energy of my light even more, you can notice that my electrons, they are moving faster and faster and faster. If I decrease this frequency, if I decrease the energy of my light, the electrons, they are moving slower. So the energy of light affects the kinetic energy of electrons. And we can use Einstein's equation for photoelectric effect. You can see it now on the screen. HF, this is the energy of light that we shine on the plate. HF0, this is the work function, the minimum amount of energy that we need to just eject these electrons from the metal. And kinetic energy, this is the kinetic energy of the electrons. So more energy of light that we shine, more kinetic energy, because this work function doesn't depend on frequency, wavelengths, or anything else. It depends only on the metal itself and how it's polished and etc. Only on the metal itself. If it's lithium, we need the energy of 525 nanometers at least to just eject these electrons from this metal. And anything else that we have more than this energy will go for kinetic energy of these electrons. This is how it works without any voltage applied here. And now let's talk about voltage that we can apply. Here we can see that we have some U0 equals 0.42 volts. What does it mean? Actually, we call it stopping voltage. This is the voltage that we have to apply to stop them completely, to stop these electrons completely. I want to change it a little bit. Let's do it like 0.39 volts. And now I will apply voltage 0.4 volts. And we can see that our electrons, they stop completely. they cannot reach another plate. I stop them completely by the electric field between these plates. This tube is evacuated, no air inside. An electric field does work on these electrons and decelerates them. So all the kinetic energy that these electrons had here in the beginning is converted to work of electrical field. So work of electric field just decreased this kinetic energy to zero, completely decreased this kinetic energy to zero. This is what we call stopping voltage. And if we apply less than stopping voltage, for example 0.2 volts, yeah, we still have current in circuit. We still have current in the circuit, but of course the kinetic energy of these electrons is not the maximum that they could have, because we anyway decelerate them. We decelerate them by this electric field. Electric field still does work on these electrons, so they have less kinetic energy when they reach another plate. You can see if I have no voltage at all, they are faster. If I have 0.2 or 0.3 volts, they are slower. And if I have 0.4 volts, I can stop them completely and wow, we have no current in the circuit. Now let's do like this. Let's decrease the frequency of the radiation. Okay, now I just ejected the electrons from the metal, but they have no kinetic energy at all, and of course cannot reach another plate. But let's help them. Let's apply voltage like this, that here we will have minus sign, here we will have plus sign, so electric field has to do work on these electrons, and in this case it will accelerate them, so we can help them and they will reach another plate. Let's do this. For example 0.2 volts. And now we have current in the circuit because we help these electrons to reach another plate. Now electric field accelerates them because do you remember the charge of an electron is negative. So if it's minus here and plus here, electric field accelerates these electrons. And if they had no kinetic energy at all in the beginning, now they have some, and this amount of kinetic energy that they have when they reach another plate is equal to the work of electrical field between these plates. This is how it works.
Okay, let's go. If the electric cell is connected in series with a battery of EMF 2 volts, photons of energy 6 electron volts are incident on the cathode of the photoelectric cell. The work function of the surface of the cathode is 3 electron volts. What is the maximum kinetic energy of the photoelectrons that reach the anode? Okay, we can see the loop here, yeah, and we know about energy of photons, we know what the voltage we apply here, right? So you really need this information that I gave you the last lesson about how it will change the kinetic energy of electron. So first you can use the equation of Einstein for photoelectric effect, right? And then you can apply this knowledge that I gave you the last lesson to understand how will the kinetic energy change.
So I say HF equals HF0, its work function, plus E kinetic initial. E kinetic initial. It's okay if I write like this?
Yeah.
Okay, but then they go through the electric field, they go to another plate, right? And if now I also have some electric field here, really, if this electric field can do work on them, this electric field can accelerate them or decelerate them. If this electric field decelerates them, so of course it will change the speed, it will decreases it's their speed. Okay, delta E kinetic equals what? E kinetic initial minus work of electric field minus EV actually. But if this V is not stopping V but less, you see, we just change the kinetic energy, but we don't stop them, so they still have some kinetic energy, right? And oh, actually it's not true, it's E kinetic final, right? E kinetic final minus E kinetic initial, but of course it would be like a negative number, right? Because E kinetic final less than E kinetic initial. But it's okay, it should have been negative number because the work of electric field decelerates them. How it's supposed to be. Equals.
Just 1 second, let me just digest this.
Digest. The initial plus the work of electric field delta E kinetic.
Couldn't this then be like negative? No?
Yeah, it has to be negative, and I wrote it down now. Like, yeah, when you will get the number, it will be negative. This number will be negative, yeah. And here, the second case, you see, when it accelerates the charges, the electrons, the delta E kinetic will be for sure positive. It's always final minus initial, but this time final will be greater than initial. And now the work will be positive. So
the battery has plus side here, right? And minus side here. You know this, right?
Yes.
And so what does it mean? If here it's positive, it means that this is positive as well, and it will be negative here. So how it will affect electrons? It will accelerate them, or decelerate them? How do you think?
Accelerate.
Accelerate. So here we have photoelectron. Photoelectron.
Oh, electron is negatively charged, right?
So
decelerate?
Yes, absolutely right. The electric field will decelerate the photoelectrons, and of course it will affect the kinetic energy, right? So the kinetic energy will be decreased, and we have to calculate how much will be decreased. So okay, let's first write the equation, maybe somewhere here, the equation of Einstein for photoelectric effect. Okay, actually they already gave us work functions, so HF0 equals 3 electron volts, and HF they already gave us as well 6 electron volts. So 6 minus 3 equals 3. Okay, we know the kinetic energy, the initial kinetic energy is 3 electron volts. Okay, this is the initial kinetic energy, right? So this kinetic energy, these electrons, they possess this kinetic energy in the beginning, right here, at this point when you just ejected this electron. And then of course it has some kinetic energy and it will go to this direction, to the right, yeah. But here we have electric field, plus here minus here, and this electric field, as you already understand, will decelerate this electron. So when it will be here, our electron, it will have already less kinetic energy than before, so E kinetic final, we can say, yeah. So we want to find E kinetic final here. QV equals EV in our case, because Q is E, yeah, in joules. If we want to convert joules into electron volts, we have to divide joules by the charge of an electron, by the magnitude of charge of electron. And then we will get electron volts. But it's about units. It's units, not a formula. It's units. Just how we denote this unit.
So let me read the whole process.
Mm-hmm. 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 Yeah. Mm-hmm. Yes, 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 absolutely.
Okay.
You know, right? More energy for when we don't have photoelectric effect, when we have not enough energy. But when energy is not enough, we have some threshold energy for photoelectric effect to start occurring. So you understand, we have to increase the energy or decrease the energy to start photoelectric effect being
Increase.
increased for sure. So if you want to increase the energy, you have to decrease wavelengths or increase wavelengths.
Increase.
Opposite frequency increase, but wavelengths always opposite decrease. If the wave is shorter, this wave has more energy. Okay, next one with our pictures here. The diagram below shows a circuit involving a photoelectric cell. When UV light is shone onto the metal cathode, electrons are emitted, establishing a photocurrent. Okay, which of the following changes could cause the photocurrent to stop? Okay, we want to stop. Yeah, we have plus here, minus here. Absolutely right. I agree with you. So we have a voltage applied in opposite. So it means if we will increase the potential difference, we will increase the voltage here and can come to this stopping voltage, can get this stopping voltage and will stop them and have no current in the circuit. Absolutely right. Okay, red light, metal surface, collecting plate, ampere meter, and battery. The potential V of the supply is varied and the current is measured. The results are shown on the graph. We have current, here we have voltage. The light source is changed to blue. This blue source emits the same number of photons, so it means the intensity is the same, per second as the red source. Which graph shows the variation with potential of current for blue light? The results for the red light are shown as a dashed line. Okay, again, we had red light before. Now we will have blue light. So the energy is more or less now more, right? What is this voltage?
Wait, hold on. Why is energy more? Energy.
You said more or less?
More.
More, absolutely right. Blue light has more frequency, more energy, less.
I thought red light has more frequency, no?
Red light has less frequency and longer wavelengths.
Really?
Really?
I thought like red light's like and blue light's like
Absolutely opposite.
Really?
Really?
Okay.
Wavelengths. And here you have to understand first, what is this voltage? Do you remember? What is this voltage here?
This is 0.
No, it's not 0, 0 here.
Oh.
But this voltage has some special name.
Stopping voltage.
Stopping voltage because we have no current if we have this voltage, right?
Yes.
Yes, absolutely right. Do you remember how the change in energy of the incident light will affect this stopping voltage?
Can you repeat that slower?
How the energy of the incident light will affect the value of stopping voltage that we need to stop all the electrons.
Well, if
we have more energy of incident light, how do you think? We
then
need
stopping voltage has to be bigger as
yes,
well.
yes, absolutely right, bigger as well, because we will have more kinetic energy now, right? And to decrease all this kinetic energy to zero, we need more, like, just more powerful electric field, so we need more voltage. So now you already understand what will happen with voltage. It will go to the right or to the left, this stopping voltage.
To the left.
To the left, absolutely right. Intensity is the same, voltage is bigger, and dashed line is the previous line. Okay. But is it easy to solve this problem, right? If you just know this, if you just understand this concept, easy to solve.
Read the question carefully.
Oh, so easy.
Really?
Really? Yes, it could be not maximum after going through the electric field, if this electric field is accelerates or decelerates them, but they said emitted from the surface. They don't say anything about voltage here, you see, so just emitted from the surface. The maximum kinetic energy is like this. Okay, and the last one is number 20. Monochromatic light is incident on a metal surface and electrons are released. The intensity of the incident light is increased. What changes, if any, occur in the rate of emission of electrons and the kinetic energy of the emitted electrons?
Well, rate of emission of electrons also increases. So the kinetic energy, no change.
No change, yes. D,
So
right?
D.
Yes.